In this video, I'm going to show you how to use the TI-Nspire in its spreadsheet function to do Euler's method. This is problem 17 from the textbook. It's on page 1473. You can see that the differential equation is given by dy dx equals x squared plus y squared. And there's initial value when x equals 0, y is equal to 2. The directions say use a step length of 0.25 to find an approximate value for x equals 1. So from x equals 0 to x equals 1, that's 4 steps away. First thing I'll do is start my calculator. And here we have a spreadsheet. And I'll need to name several columns. This first column, I'm going to call it x0 for our initial value of x. The next column I'll call y0 for our initial value of y. This column I'm going to call h. It is going to be the space between x's. So the step is 0.25. So here I'm going to put in equals 0.25, and when I hit enter, it automatically fills this row with everything. And I was going to call this H, okay, like this. This column D, I need my slopes. So the slope is going to, I'll call it M for slope, but I'll need to put in a formula that will be different in every row as the slope changes. This column will be equal to x1, our new x, and this column will be equal to y1, our new y. I need to start off with x equal to 0 and y equal to 2. The slope is going to be, here's where I'll need to put a formula into my cell. I'll type the equal sign, and then I will type A1. This is the cell right here, and this needs to be squared. So this is using your calculator, you can do this. And I need to add B1, this cell right here, and it needs to be squared. I'm not typing in 0 squared or 2 squared. I'm using the cell addresses. If this goes well, which you can see it didn't, it will give me exactly what I want. Somehow I missed the 2 here. And here I should be seeing the number 4, but I'm not, so I have to investigate why. The reason I wasn't seeing the number I expected, I typed A1 here correctly, but I typed B2, and what I really need is B1. So now I see the number 4, which is the correct slope. X1 is equal to cell A1 plus what is in cell C1, and 0 plus 0.25 is 0.25. Well, that looks good. And Y, this is equal to cell B1, which is my old Y. Well, let's see, let's do it this way. It's equal to the slope, which is cell D2, and that has to be multiplied by cell it's D1. I don't want to make that mistake again. Times cell C1 plus the original value for Y, which is B1. So that's 3. Okay. Once I've done that, I can there's a little more to do. This is equal to cell that was called X1. I've forgotten what that looked like. So over here, that was E1. And this is equal to cell 1. All right. So now my situation is I have to do a fill. So I want to use, these are formulas that are in here. This is the formula equals E1. And all the other cells that I filled starting with an equal sign, they're all cells that are filled with formulas. So I want to fill this down so that I don't have to repeat and type everything for every single cell. It's too much like real work. So I hit menu, I hit data, I hit fill, and then I hit the down arrow, and I'm going to go down, I don't know, I'll go down to 9, and then I'll hit enter, and this, whether you can see it or not, this has been filled with all the different cells, formulas. This is filled with the equals E2 formula. It's what I want. I'm getting a little dash here because right now there's no number to put in. I'm going to do a fill repeatedly for all these other columns. So in the B column, I hit menu, I hit data, I hit fill, and I go down arrow, down arrow, down arrow, down arrow, down arrow, down arrow to here and hit enter. And you can see right here that the formulas are in there. There's no number for them yet. This is the formula I want, but again, I want to fill down for slopes, for differential, data, fill, down arrow, enter, repeat, menu, data, fill, down arrow, enter, menu, data, fill, down arrow, enter. Now I'm going to change my view so you can see everything. View, document preview, computer. And this is it. We have all of our steps. We only needed to go to 1, and we have our approximation for y at 49.9. You can see as you go along here that when we get up to x being equal to 1.5, our approximation is a little bit over 110,000, a little over 114,000. And next for 1.7, we see 3 point whatever. If you click into this, you'll see this is 3.27 times 10 to the 10 to some big power here. See if I can figure it out. Well, it's a big number. The next one underneath is 2.68 times 10 to the 18th power, which is truly huge. So these have gotten beyond the range of what the calculator can show you in the space provided, so it's switched to scientific notation. But this is how you do Euler's method with a spreadsheet on the TI-Nspire. Key lesson here is how to use the formulas, enter the formulas, and use fill so that you don't have to type every single formula individually in every single cell.